Welcome back to Math Concepts. In this video we are going to go over one more alternative to checking whether or not an argument is valid. Okay, so far we have truth tables, and that is something you may need to fall back on. They work all the time. We talked about a couple special standard forms of arguments, and you can use those to check if the argument you're working with falls into one of those categories. And in this video we're going to talk about a third one, circle diagrams or Euler diagrams. They can be pretty helpful, especially if your argument involves conditional statements. So we'll switch over to the document camera and look at examples of using these circle diagrams. Alright, so the key idea for this video is be able to use circle diagrams to determine whether an argument is valid. And circle diagrams work best when your argument involves conditional statements. So, what we've got here is an argument. If it's a poodle, then it's a dog. If it's a dog, then it's a mammal. Therefore, if it's a poodle, then it's a mammal. Now, we could use one of our standard forms on this argument because if we write it out in symbols here, we can see very clearly if it's a poodle, then it's a dog. Okay, so poodle implies dog. If it's a dog, then it's a mammal. Dog implies mammal. And the conclusion was, if it's a poodle, then it's a mammal. And we can see, okay, this is transitive reasoning that we discussed in our last video. But let's look at how we could show this is valid using our circle diagram. Okay, so the first premise of the argument tells me about kind of a containment. It says the set of all poodles is contained in the set of all dogs. So we'll draw a circle for the set of all poodles. And by that first statement, the set of all poodles is contained in the set of all dogs. So P for the set of all poodles, D for the set of all dogs. Now, the second premise is about the set of dogs and the set of mammals. It says the set of dogs is contained inside the set of mammals. Okay. Now the last line here, the conclusion of the argument, says the set of poodles should be contained inside the set of mammals, and we can see that works from this circle diagram. So this is a valid argument based on the circle diagram. Okay, let's go and check out a couple more examples just to get the hang of this. Okay, so here we've got another example argument. So we're going to determine whether this argument is valid. So my premises are no prime numbers are negative. 7 is not negative. Therefore, 7 is prime. Okay, let's look at a circle diagram for this. Now this is a little bit different than what we had before. This says no prime numbers are negative. Now up here it was basically saying every poodle is a dog. So there was a containment between the set of poodles and the set of dogs. This set is contained inside this one. But of course this is a little different right here. No prime numbers are negative. So that means that we have the set of prime numbers over here and the set of negative numbers over here. Okay, those two sets are apart from each other. Okay, now, the next premise says 7 is not negative. So that's telling me where to put 7 in relation to this circle. So for example, I could put the number 7 right here if I wanted to, right? That's outside the circle for negative numbers. Okay, so this fits the second premise. Their conclusion says, therefore, 7 is prime. So this is not a valid argument. Okay, this is not a valid argument. Now, this is an important point to understand when we're talking about an argument being valid or not. Notice the conclusion here is true, okay? But determining whether or not an argument is valid does not simply mean the conclusion is true. It means the reasoning is correct. Okay, let me give you an example here. If I say tomorrow is Friday, that's a true statement. I'm making this video on a Thursday. Tomorrow is Friday. So if somebody says, well, okay, how do you know tomorrow is Friday? And I say, well, it's sunny out today, and whenever it's sunny, the next day is Friday. My conclusion is correct. Tomorrow is Friday. But the reasoning I used to get that conclusion is wrong. So my argument is not valid. This is the same situation here. Their reasoning says, okay, no prime numbers are negative. So that's depicted in this diagram. The set of primes is separate from the set of negatives. 7 is not negative. So this statement does not say 7 has to be in this circle, which is what the conclusion is. The next premise simply says that 7 has to be outside the circle for the negatives. So it could be in here, or it could be someplace else. So that argument is not valid. Okay, so one more example should be enough to give us the idea. Okay, so determine whether this argument is valid. And we're going to draw our circle diagram, or as the book calls it, an Euler diagram. Most teenagers drink soda. All right, so once again, a slightly different setup than what we saw in the last two examples, which is good. We want to get a variety of different types of arguments and see what applies to what. Okay, so it says most teenagers drink soda. So that is saying there should be an overlap between the set of teenagers and the set of soda drinkers. Okay, there should be an overlap between the set of teenagers and the set of soda drinkers, but it should not be the case that the set of teenagers is contained inside the set of soda drinkers. In other words, I think we need something like this. Set of teenagers, I'm just going to label that with a T. The set of soda drinkers, maybe something like that. Okay, so this is demonstrating what this first premise says. Now, the second premise says no CEOs drink soda. Okay, so I'm going to need another circle representing the set of all CEOs. Now, this premise tells me the set of CEOs has to be outside the set of all soda drinkers, but it doesn't say anything about the set of teenagers. So this circle I'm drawing right here, this circle fits the second premise. Okay? That set is away from the set of soda drinkers. Okay, and the conclusion says, therefore, no teenagers are CEOs. Well, this is not a valid argument. Okay? We drew a diagram that fit the premises, but this diagram is not supporting the conclusion, right? There are teenage CEOs if we follow these two premises. So this is not valid. Okay? So you have a valid argument if your diagram demonstrates that the conclusion has to be true based on a diagram that follows the premises. we drew a diagram that followed the premises. Most teenagers drink soda, so we have the set of soda drinkers overlapping with the set of teenagers. No CEOs drink soda, so the set of CEOs right here is outside the set of soda drinkers. But the premises did not say the set of CEOs had to miss the set of teenagers, but that's what the conclusion is claiming, and that's why the argument's not valid. Okay, so that is another tool for helping you determine whether an argument is valid. So we have truth tables, we have the standard forms, and now we have these circle diagrams or Euler diagrams.